Hey, Mr. Herodimandarian here. We're going to go over how to do the ideal gas law with density here. So what would the density, so this is the density we're going to be looking for. Now since this is a gas, we're doing grams per liter because it's a gas. That is what we measure densities in for gases. Of oxygen gas at 70 degrees Celsius, you're right, Darian, we cannot use 70 degrees Celsius. We have to use 343 Kelvin. So the temperature here is 343 Kelvin and 3 atmospheres. So the pressure here is 3 atmospheres. Now we actually know something else here too that's not listed. We actually know the molar mass of oxygen as well, which is 32.00 G moles. Down with the gangsters. Okay? So here you're going to see me use molar mass equals dirt P is what you're going to see me use. So you're going to have to see me find an R here. Here the pressure is in atmospheres. So I'm going to use 0.0821 liters atmospheres moles Kelvin. Okay. I could do the algebra first. Should I do the algebra first? Sure, let's do the algebra first this time. So we got P on the bottom here, right? So we got to multiply by P so it moves over there. So now we have molar mass equals P dRT. Then you're going to see me divide by RT. So I divide both sides by RT. So these cancel and these cancels. So I know that D is equal to molar mass P over RT. So D is going to be equal to 32.0 times 3 divided by 0.0821 divided by 343. And I probably should have put my units in for some of these things. So I'll go back and do that. And I usually don't put in units for R because I just don't. And then we get a density of 3.41 grams per liter. Remember, this is a gas. Units have to be grams per liter because here's why. There's a grams here, right? And then if you look at your liters, atmospheres, moles, Kelvin here, da 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 da. Kelvins cancel, moles cancel, moles cancel, atmospheres cancel, leaving me with liters. So that's why it's grams per liter when we do the ideal gas law with density. Okay. Let's look at the next one here. If the density of a gas is known to be 1.96, so we know the density of a gas is 1.96 grams per liter. So already here, since we're doing a gas law problem here, I'm going to do the molar mass equals dirt P equation here. At 755 torr, we know that 755 torr is the pressure. And 5 degrees Celsius. You're right. We have to use 278 Kelvin. Okay, for the temperature. What is the molar mass? And the molar mass is in G moles. Down with the gangsters. Of the gas. So we gotta pick an R here. Okay, so we have liters, torrs, moles, and Kelvin here. So I'm gonna pick 62.4. Liters, torrs, moles, Kelvin. Oh, this is nice. I just don't have to do any algebra. I just have to plug these numbers in. Oh, nice. 1.96 grams per liter times 62.4 times 278 Kelvin divided by 755. And we solve that. Molar mass is equal to 45.0 grams per mole. G-moles, down with the gangsters. This is ideal with density. Okay. Let's look at example 1126. Okay. Here's a problem I've already solved for you, but I'm going to solve it a different way this time. Okay? This time I'm going to use the ideal gas law to do this, which might be easier. Okay, so Harry has 200 milliliters here. So 200 milliliters is our volume. Okay, since I'm going to use the ideal gas law, I'm going to convert that over to 0.200 liters to start. Of oxygen in a flask and 790 torr, so 790 torr. At 20 degrees. So that's going to be 293 Kelvin. Okay. So the R I'm going to use for this one here is going to be 62.4. And you're going to see me find the moles. Okay. You're going to see me do that the first time. Then you're going to see me do this. 300 milliliters. Okay, that volume is going to be 0.300 liters. Okay. 600 torr, so this is going to be, the pressure is 600 torr. Okay. And the temperature is 80 degrees Celsius. Which is 353 Kelvin. You're going to see me use R again here of 62.4. And then you're going to see me find the moles again. Okay? So then I can add these two number of moles, and I'm going to find my third number of moles eventually. I have a volume of 1.75 liters. I am looking for the pressure in torr. I have a temperature of 25 degrees Celsius, which is going to be 298 Kelvin. Okay. And then the R here, this time I'm going to use 62.4 again. Okay. So the key to this is that this plus this is going to equal that. Okay? And you can't just combine these, and no, you have to solve this first and solve that second, and then you're going to have to solve that third. So here's the first one you're going to see me do is PV equals nRT 790 torr times 0.200 liters equals N 62.4, and the T is 293. Okay, and I don't have that solved. So 790 times 0.2 divided by 62.4 divided by 293 is N is equal to, and I'm going to write this out because I don't want to round yet until I get to the end. Okay, so that's the first one I did. Now I'm going to do the purple one next here. Gotta do PV equals nRT. So this is 600 torr times 0.300 liters equals N 62.4 times 353 Kelvin. N is equal to 0.0081711715 moles. So now I'm going to add these two number of moles. So I have my new moles of N is 0.0168135 moles. So now you're going to see me do PV equals nRT a third time here. This time I'm going to use, I'm looking for the pressure. I got 1.75 liters, 0.016835 moles, 62.4, and the temperature is 298. And I got 178.6, which rounds to 179 total. It's another way to do a problem that we have seen before. Okay, and I use the ideal gas law separate 3 times. That was a difficult problem, Darian. But these guys are champions, so we're okay with that. Okay? Legend is out.